Hey you guys, so we're looking at 9.5 today, and that's working with rational exponents. And just remember, rational means fraction, okay? So when we say rational exponents, we're talking about fraction exponents. What I want to show you guys to start with is just how to convert an exponent into a radical, okay? So here's two examples of exponents, and we're going to try to make them look like radicals, which means I'm going to build a radical over here, and I'm going to build a radical over here as well, okay? Now, the rule is if you take your base, okay, which for example is like this a value here or this a value here, that always has to go under your radical. So I'm going to put an a value right under my radical in both cases. Now the rule is whatever number is in your denominator can actually go as the root of the radical. So for example, like this n, see how it's your denominator of the fraction? It can go right here on your radical. And then this n is also a denominator, so it can go here. And then your numerator, which would be like this 1 on this example, or this m on this example, your numerator actually goes inside of the radical. So the 1 would go like right here in example 1, and the m would go here in example 2. And so that's just converting from exponential form, which is here, all the way until radical form, which is here, okay? So we're going to practice, and what I'm going to do, since it says on these examples, and I'm only going to do the odds for you guys, just because that's typically what we choose for the checklist, it says turn each expression into radical form. So what I'm going to do for all the odds is I'm going to build us a radical so that we can work with it, okay? So for number 1, I'm going to build a radical. Number 3, I'll build a radical. Number 5, I'll build a radical. Number 7, build a radical. And number 9, build a radical, right? So now that I have all my radicals built, I'm just going to try to practice and see what the base is. So now I'll take the base. So obviously, like, the base is x. This base is 24. This base is actually AB, which is interesting. This base is only 12 if you look really carefully, and there's a W there as well. So what I'm going to do is I'm going to just follow the rule. My base has to go underneath the radical. So this x as a base goes under the radical. This 24 goes under the radical. This AB goes under the radical. And this 12W goes under the radical. Oops, I forgot number 5. Give me a second. There's a K as a base, right? So let me slide a K under the radical as well. Okay, now the next thing says that for the rule, you have to look at the fraction exponent and take the denominator and put it on the outside where the root goes. So I'm going to highlight all my denominators in blue. The 4 is the denominator. The 3 is the denominator. The 2 is the denominator of the fraction. The 4 is the denominator of the fraction. The 2 is the denominator of the fraction. What I'm going to do with all those denominators that I just highlighted is I'm going to put them on the outside as a root. So there's a 4th root here. There's a cube root here. This is just a square root. There's a 4th root here. And this is a square root as well, right? So you guys see how I took all those blue highlighted denominators and I put them outside. Well, now I'm going to go ahead and change my highlighter, and I'll put the highlighter in, let's do orange. And I'm going to do all the numerators of the exponent. So numerator has 1, numerator has 1, numerator has 7, numerator has 3, numerator has 1, and I'm going to write those where they belong. The numerator goes underneath the radical as a power. So this is x to the first, this is 24 to the first, this is k to the 7th, this is ab to the 3rd, and it's actually your whole ab to the 3rd. We have to be careful there. This is 12 to the, and it's actually a whole entire 12w is the base to the first power, right? And then you're done. The only thing, this one's kind of unique because you have an extra 7 on the outside, so he just kind of stays outside where he belonged, okay? But that's how you convert. You basically take your base and you write it underneath the radical. The denominator has to go as a root of the radical, and then the numerator has to go as the exponent underneath the radical. And then the other way to convert would be to take something that is already in exponential, or excuse me, already in radical form and turn it into exponential. Now that would look more like this, okay? So now we already have the radicals, and now your goal is to write it as an exponential form. So what I'm going to do is just reverse everything I just did. Now I have to find whatever's under the radical and make that my base. So let's do this. Here is under the radical, so that's my base. Oh, that's number 10. Let's do 11. There's my base, and there's my, nope, that's number 12. I'm sorry. There's my base. This K is my base. This 3M is my base. This, well, for 17, it gets pretty interesting because you actually have the entire base of 10 to the 5th a cubed b. That whole thing has to be your base, right? And then here, well, 18 is even as well. I keep wanting to do evens. So let's write all of our bases out so we can figure out what the exponents would be. On 11, your base is x, y. On 13, your base is 11. On 15, your base is 3m. On 17, your base is the entire 10 to the 5th a cubed b, right? Now what you're going to do is you're going to have a fractional exponent. So I'm going to put a fraction up here. I'm going to put a fraction up here. I'll put a fraction up here. And I'll put a fraction up here, okay? And you really have two spots to fill. You have to fill the top of your fraction, right? Which is going to put like a number up here. Then you fill the bottom of your fraction, which puts a number down here. Same thing, fill the top of your fraction, fill the bottom of your fraction. Fill the top of your fraction, fill the bottom of your fraction, fill the top, fill the bottom. Now, if you remember from the previous problems, the numerator of your fraction will always be the whatever the root is in your problem. So I'm going to grab that blue. I can even remind you, look up here. See how every single bottom of the fraction is in blue, right? You have the 4 down here in blue. You have, here I can point to it for you as well. So you have like the 4 down here in blue, you have the 3 down here in blue, you have the 2 down here in blue, the 2 down here in blue, the 4 down here in blue. Well, notice they all went where the root is of the radical, right? Every single time. So what I can do is I can take wherever the root is, whatever number is there, I can put that on the bottom of my fraction, right? So let me grab my red pen. And notice here, there is nothing in this space where the root is. Well, that's just a square root, right? Because it's kind of an implied invisible 2 there. So I'm going to put a 2 down there. For this one, you can see there's a 3, number 13, so I'll put a 3 down there. For this one, again, it's invisible, but there's an implied 2 there, so I'll put a 2 down there. For number 17, there, again, there's nothing there, so it's probably just a square root, right? So I'll put a 2 down there. So now I've taken all the roots off of my radical and put it at the bottom of the fraction in my exponent. The last thing you'll remember is that the numerators were all in orange, right? So look at number 1, there's a 1 up top. Number 3, a 1 up top. Number 5, a 7 up top. So what I do is that goes to the top of my fraction. So what I can do is take these bottom ones that I'm reversing the order, and I can write them as the numerator of my exponent. So whatever number I see here, which obviously there's nothing there, which makes this an implied 1, or for number 13, you guys will see a little square there, right? That means I have a 2 up here. For number 15, there's a 7 up there. That means I put a 7 on top. For number 17, really, if this was my base wrapped in parentheses, there's just like an invisible 1 up there that I don't quite see, but I would put a 1 up top, right? So again, that's how you would kind of convert one way to the other. You can either take an exponential and you can write it as a radical, or you can take a radical, you can write it as an exponential, right? So you're just trying to work yourself back and forth from one version to the other, and you see that those odds can be done for you there. Now on the back side then, what you're trying to do is use these same exact rules but simplify along the way. So you might have to like combine something or add something and then convert it when you're done. So you'll notice these 3 steps. It says, first of all, can you rewrite all radicals as exponents, right? So we'll do that if needed. Rewrite all radicals as exponents. So that's this step 1. The second step says use any exponent rules. That means anything from 9.1, 9.2, 9.3, 9.4, and you want to try to see if you can use the exponential rules to simplify. When you're done, write your answer as a radical, which is what we just kind of practiced doing right there. Okay? And then rationalize if needed. We're probably going to have to practice rationalization, but that's coming soon. Okay? So let's check out how these look. And I'm going to do kind of go zoom in here so you can really focus on one at a time. So let's do number 19 first. So for number 19 then, basically, do you guys see how you have x's that are being multiplied together? Well, our rule always said if I want to multiply the x's, I should actually just add up their exponents. So a 1/3 plus a 1/4 would give me an x to the 5/3, right? And typically that could be my final answer, except we have to write this as a radical. We just practiced that. That means find your base first. Well, here's your base as an x, okay? So let's write this as a radical. Let me build a radical. Your base is x, which means your x goes here. Now your numerator, which is 5, and your denominator, which is 3, just remember, you guys, your denominator goes here, and your numerator goes here, which means, to finish this problem, I can put a cube root right here, and I can put a 5 right there. Here's my final answer, the cube root of x to the 5th. Okay, let's try 21. So 21, interesting as well. That's another rule. That's from 9.3, I believe, was subtracting, right? So in this case, you have an m 5/2 divided by an m to the 7/4. Well, that means you subtract these two exponents because you're dividing. So let's find out what 5/2 minus 7/4 would be. Well, you can't really do this without common denominators, so you should change this fraction right here into fourths. So let's see, if I were to multiply by a 2 down here, that means I'd have to multiply by a 2 up here as well. So this fraction can actually change into 10/4, right? This is a 10, sorry. So then 10/4 minus 7/4 would get me 3/4. So now this answer is actually an m that's being raised to the 3/4. And you're pretty much done there. The only problem is we have to write it, like I said, as a radical. That's kind of the purpose. So let's build yourself a radical. Find your base, which your base here is this m. So you can write your base down here as an m. And now remember, the bottom of the fraction should go here, and the top of the fraction should go here, which means you want to build a 4th root of m to the power of 3. This is your final answer. Okay? And we'll just keep working through a couple more here. This is your power rule. So with the power rule, you have 32 to the 1/2 to another 1/2, which means this 1/2 has to get in on this 32 to the 1/2. Well, 1/2 times a 1/2 is going to get you a 1/4, which means your answer is actually 32 raised to the power of 1/4, like that, right? Well, if 32 got raised to the 1/4, we could easily write that as a radical, which is what they asked us to do. So create a radical. Well, here's how you would do so. You would take your base, which is clearly 32. So let me build a radical for us real quick. Build your radical. Put your 32 inside. And then, like we've seen now, your bottom can go right here. And your top can go right here. That's kind of the way it goes, right? So put your 4th root of 31 to the first power. And then you can actually check if this has an answer, right? You could like type in on your calculator the 4th root of 32 and see if you get anything, okay? But for now, I'll just leave it like that, the 4th root of 32, okay? The next one is 25, and this is interesting because now you have a negative exponent. You guys will notice, like, you're using every single rule that we've gotten through to this point. So the rule is if I have a negative exponent, I can make it positive by sending it below a fraction. So what I'm going to do is I'm going to build a fraction here. I'm going to take my 100 to the negative 1/2 and put it down low, which will make it 100 to the positive 1/2, right? And I can just put a placeholder as a 1. Well, this is pretty solid. The only thing is I actually am going to need a radical, right? So build a radical. And in your radical, what you'll have is find your base. So my base is here as 100. So I'm going to put 100 in my radical. I actually need to make this a little bit smaller just because I'm going to have to build a fraction anyways. So there's a 1 up top. My radical should be down here. That's better. So I put 100 inside of it. And then whatever's on the bottom, which is this 2, has to go here. Whatever's on the top, which is this 1, has to go here. That means that I have a 1 over 2, right? So really, I can simplify this for sure because 1 over a square root of 100 is just a 1 over 10, right? Because the square root of 100 in my calculator is 10 if I type it in. So the answer is just 1/10, okay? And we'll just get a couple more good ones here. We got like maybe 4 left. We'll try to keep it moving. This one, very similar, right? You would just say that this negative 216 being raised to the negative 1/3 power, again, a fraction because we're not allowed to have these. We're not allowed to take negative exponents like this. We can't do that. So what we do instead is we just say, okay, this is going to have to be 1 divided by a negative 216 that gets raised to the positive 1/3 power, right? Like that. So if that's the case, you'd want to build a radical, right? You could say that this is 1 divided by, let's make your radical, find your base, which your base is going to be right here as a negative 216. Okay, so put your negative 216 in here. And then by now, hopefully you're understanding there's 2 locations. There's this denominator, which goes here, and there's a numerator, which goes here, which means this denominator should be a cube root, and the numerator, which would have went here, should have been a 1. Okay? So once you have that, this simplifies even more because you can find a number that will multiply by itself 3 times, or just grab your calculator, of course, and look for the cube root of a negative 216, right? So it's like what can be multiplied by itself 3 times to get negative 216, and of course this answer is 1 over a negative 6, right? Because think about it this way. If I took a negative 6 and multiplied it by a negative 6 and multiplied it by a negative 6, this is essentially negative 6 cubed, which equals negative 216. So that means that the cube root of negative 216 has to be negative 6, right? Because it multiplies by itself 3 times. So that's another good example there. And just a couple more. If you have a cube root of v that's now getting multiplied by the square root of v, what you guys can do is turn this into fractional exponents. This is the reverse method of what we've just done, right? Because if you think about it, if you have a base of v, look at your locations. This should be the denominator, and then I know it's not there, but this should be the numerator. So I can even slide in an invisible 1. That means that this whole situation here actually becomes a base of v that gets raised to the 1/3 power, right? Because of the locations. The blue is always the denominator, the orange is always the numerator. And then I can multiply. I can do the same thing with this one. Check the locations. This would be a, let me just get my colors sorted out. Here's your denominator, here's your numerator. Since they're both invisible, you got to slide them in. So there's an invisible 1 as a power, and then if I build a square root that has no number, I know it's a square root, right? Because that's kind of the default. So that means that this is a v. If I follow the locations, it's to the 1/2. And then you guys will remember whenever I multiply two letters together, see this multiplication dot? That actually makes me add the exponents. So this would be a v to the 1/3 plus 1/2, like this. The only problem there is, again, you would need common denominators. So let's see, they can both go to 6. What I would do is I would multiply this by 2 on the top and by 2 on the bottom. I'd multiply this by 3 on the top and 3 on the bottom. So that would actually end up getting me, if I change back to red, that would get me a v raised to the 2/6 power times a v raised to the 3/6 power, which is a v raised to the, remember, you're adding these up to multiply, 5/6 power, and that's like this. And then if you absolutely had to, you could convert that back into a radical, which would be a radical that has a v underneath, and then again, just follow your locations backwards. This is on the top, the 5, this is on the bottom, which means the bottom goes here, and the top goes here. This could be a good acceptable answer. Either of these are pretty solid. That's a tough question, though. And then there's the last one, which would just be a conversion from a radical into a exponent, right? So what you could do here is think about the fact that a 4 by itself is like a 4 to the 1 power. So let's call this 4 to the 1st. Well, if I follow my locations for the bottom, here is your numerator and here is your denominator, right? So this is really, if I follow the pattern, this is a 4 that's being raised to the 1/3. Well, you guys know by now, when I have division with the same base, I subtract the exponents. So it's really like trying to subtract a 1 minus a 1/3. Well, a 1 is a 3/3. So I can just subtract 3/3 from a, I can subtract a 3/3 from a 1/3, which gets me a 2/3, right? So if that's the case, what I would end up doing then is just saying that this is really a 4 to the 2/3, and then I can just convert that as needed by either solving it in my calculator or using the radical to go backwards and write it as the square root of, well, here's my base, so put it down here. Here is your numerator, and here's your denominator. So you could put the numerator here and the denominator here. Although I believe that 4 to the 2/3 might also simplify in the calculator if you just type it in 4 raised to the 2/3 power. Let's see. Now, just leave it as that. It's not going to come out very clean. You end up getting a decimal, I think. Yeah, just leave it how it is. And then let's just do the last odd here so that we can wrap this up and you guys can work on your homework. The last one, you're just looking at locations, nothing too fancy here. Here's your denominator, here's your numerator, which means this actually simplifies into x raised to the 10/4 power, which 10/4 can both be divisible by 2, so x to the 5/2. That's a good answer. If you absolutely had to go into a radical, you could do a radical here. Put your base underneath like we've been doing and follow your locations. Here's the top, which should go here, and here's the bottom, which should go here, right? And that gets you the square root of x to the 5th. This is acceptable as well. Okay, so go ahead and work on your homework. If you have any questions, feel free to email me. You can set up a Zoom or whatever we need to do, okay? And hopefully you guys get a chance to look through this and kind of practice some homework. All right?